All right, so we're going to sketch the graph of f of x, which is a fourth degree polynomial. And so f of x is equal to x to the fourth minus 3x cubed plus 2x squared. And so you can see that x to the fourth is the leading term, right? That's the term with the highest power of x, okay? The degree of the polynomial is 4, because that's the highest power of x. And the leading coefficient is the invisible 1 in front of x to the fourth. And so with that information, right, leading term, we already know what the end behavior is in the graph of this polynomial function, right? From the bottom of page 2, okay, the leading coefficient is positive and the degree is even. So the left end in the graph of this polynomial function, is it going to go up or go down? What about the right end? So both the left end and the right end go up, right, like the squaring function does. Okay. All right, very good. So we already know one piece of information in the graph of this polynomial function. Okay. Now, what we need next is to find the zeros, right? The real zeros of this polynomial function, which are also the location of the x-intercepts, right? And to find the x-intercepts, right, you set the right-hand side equal to 0 and solve for x. Well, our polynomial has 3 terms in it. Each term involves a variable x, and the lowest power of x is 2, right? So we can factor out an x squared. So we have x squared times x squared minus 3x plus 2 is equal to 0. This in parentheses is a trinomial, factors with integers. It factors into x minus 1 times x minus 2. And now we have a product of 3 factors is equal to 0. So one of those factors has to equal 0. Right? So either x squared is equal to 0, or x minus 1 is equal to 0, or x minus 2 is equal to 0. Right? It's called the zero product property. Right? Product of 3 factors is equal to 0, so one of those factors has to equal 0. Okay. So in solving the first equation, we have x is equal to 0. In solving the second equation, we have x is equal to 1. In solving the third equation, we have x is equal to 2. So these are the zeros of our fourth degree polynomial, right? Put in 0 for x, the right-hand side equals 0. Put 1 in for x, the right-hand side equals 0. Put 2 in for x, the right-hand side equals 0. Okay? And they're also the location, okay, of the location of the x-intercepts. where the graph crosses or touches the x-axis. Okay. Now, x equals 0 is a 0 of multiplicity what? 2, right? So x equals 0 has a multiplicity of 2. And x equals 1 and x equals 2, right? This is x minus 1 to the first power, x minus 2 to the first power, right? So x equals 1 and x equals 2 have a multiplicity of 1, right? So at the x-intercept, x equals 0, right? Because we have a multiplicity of 2, right, with this 0. Does the graph cross the x-axis, or does it touch and churn? Yeah, touch and churns, right? This is an even number, even multiplicity. So it touch and churn, okay? At the x-intercepts, x equals 1 and x equals 2, does the graph cross the x-axis or touch and churn? Crosses, right? Because this is an odd multiplicity. Right? That's what we learned at the bottom of page 2, right? That if the multiplicity is even, the graph touches and churns. It doesn't cross the x-axis. And if the multiplicity is odd, right, the graph crosses the x-axis. All right, so now we have basically everything we need to successfully sketch this graph, right? We're not looking for perfection. So I provided you with a grid. Let's just say a coordinate plane, okay? And since all the three x-intercepts are 0, 1, and 2, I'm just drawing in the right half, okay? So x equals 0 is at the origin. And then we got x equals 1, x equals 2. Now, first let's do behavior. We said left end goes up, right? So from this far left x-intercept, the graph has to go up, okay? And it can't come down and touch the x-intercept or x-axis again, or we'll create another x-intercept. Okay. The right end goes up, so at the far right x-intercept, right, at x equals 2, the graph has to go up. Can't come down and touch the x-axis again, or they'll create another x-intercept. And now you use deductive reasoning to fill in the middle, okay? We said at x equals 0, right, at the x-intercept, x equals 0, because of the even multiplicity, the graph is going to touch and churn. So to the left of x equals 0, graph has to come down, touch the x-axis at x equals 0, and then turn back up again. Can't cross. Okay. We know that the graph is going to cross the x-axis at x equals 1. So the graph has to form a turning point and then come down and cross the x-axis at x equals 1. And we know the graph is going to cross at x equals 2. So the graph has to come down, form a turning point, and come up and cross the x-axis at x equals 2. So between what we know what is happening at the x-intercepts and what the end behavior of the polynomial function is, we have a crude sketch of the polynomial function. Okay. And that's all it is a crude sketch. Okay. Any questions on that, ladies and gentlemen? Okay. All right. So if you flip over to page 4, we got one more. Now this is a factored polynomial. All polynomials can be factored. Okay. So this is a factored polynomial. Okay. So we factored this 4th degree polynomial, right? This is like the general form for the polynomial. And then if we can replace this with the 3 factors, okay? So we factored form for this problem that we just completed. Is f of x equal to x squared times x minus 1 times x minus 2. That's this polynomial, 4th degree polynomial up here, factored. Okay? So every polynomial can be factored. And so an example on page 4, the polynomial is factored for you already. Okay. And so we're going to sketch that factored polynomial. Okay. All right. So we have f of x, and I'm just going to copy it down the board. I'm going to write the leading coefficient a little bit differently. See that minus sign? That's really the invisible minus 1, right? So we have minus 1 times x minus 4 cubed times x minus 3 times x plus 2 cubed x plus 5 squared times x plus 5 squared times x minus 1 squared. Okay. All right. So from this, we're going to get a sketch of this polynomial function. Okay. So the polynomial in general form has been factored for you. Okay. In advance. Okay. All right. So we know about multiplicities. Okay. So first, let's calculate the zeros of this polynomial function. Okay. So we have minus 1 times this, times this, times this, times this, times this. And so this product, right, finding the zeros, you set the right-hand side of the polynomial equal to 0, and you solve for x. Right, that's what we did in the previous problem. After we factored we factored we set the right-hand side of the polynomial equal to 0 and solve for x. Well, minus 1 can't equal 0, right? So we have a product of 1, 2, 3, 4, 5, 6 factors. And in order, oops, I left out an important piece of information. This is equal to 0. Okay? We're finding the zeros, right, the x-intercepts in this polynomial function. And so minus 1 can equal 0, but this first factor, x minus 4 cubed, can equal 0. The second factor, x minus 3, can equal 0. The third factor, x plus 2 cubed, can equal 0. The fourth factor, x plus 5 squared, can equal 0. And then lastly, the factor x minus 1 squared can equal 0. Okay. So in solving this first equation, right, if you take the cube root of both sides and then you add 4 to both sides, you get x equals 4. In this equation, right, I can drop the parentheses, add 3 to both sides, get x equals 3. In third equation, take the cube root of both sides and subtract 2, get x is equal to minus 2. In fourth equation, take the square root of both sides and subtract 5, you get x is equal to minus 5. And then in the last one, you take the square root of both sides and add 1, you get x is equal to 1. So the zeros of our factored polynomial, so let's just make a note of this. This is a factored polynomial. The zeros of our factored polynomial are x equals 4, x equals 3, x equals minus 2, x equals minus 5, and x equals 1. Okay? So these are the zeros and also the location of the x-intercepts. Okay. Now I gave you plenty of space, right? I gave you the whole page for note taking. So I'm going to create a little table. In the first column goes the 0. In the second column goes the multiplicity of the 0. Okay? And so the 5 zeros are 4, 3, minus 2, minus 5, and 1. Okay. All right. The 0, x equals 4. It has a multiplicity of 3, right? Because this is x minus 4 cubed. The 0, x equals 3 has a multiplicity of 1. I erased the parentheses, but that's actually x minus 3 to the first power. The 0, x equals minus 2 has a multiplicity of 3. 0, x equals minus 5 has a multiplicity of 2. And the 0, x equals 1 has a multiplicity of 2. Okay. So the 0, x equals 4 has an odd multiplicity. The 0, x equals 3 has an odd multiplicity. Same for x equals minus 2. And then x equals minus 5 and x equals 1, they all have an even. They both have an even multiplicity. Okay. So remember, the 0 is also location of the x-intercepts, right? So the location of these three x-intercepts where they have an odd multiplicity, the graph is going to cross the x-axis. And two x-intercepts that have an even multiplicity, the graph is going to touch in turn. So now we know the behavior of the graph, okay, at the 5 x-intercepts. But we got to figure out the end behavior, right? We got to know which way is it going to go up or go down, okay, on each end. Well, to do that, we need the leading term for a factored polynomial, right? And so, just remember in general form, okay, this is the form of a polynomial function. And so we got to figure out what a sub n x to the n is for this factored polynomial, okay? Well, fortunately, we can do that. The degree n is easy to figure out. You just add up all the multiplicities. So 3 plus 1 plus 3 plus 2 plus 2 is equal to 11. So that's the degree of the polynomial. And so you get it by adding up the multiplicities or by adding up these exponents in the factored polynomial. 3 plus 1 plus 3 plus 2 plus 2 is 11. So our factored polynomial has a degree n equal to 11. Okay? Now the leading coefficient for our factored polynomial is this -1 up front, okay, up front the first factor. So the leading coefficient is equal to -1. This guy way out front here, okay? So the leading term has the form a sub n times x to the n, right? Top of page 1. Well, a sub n in this case is equal to -1, and x to the n is equal to 11. Now we know what the leading term is, right? The degree is odd, and the leading coefficient is negative. So if the degree is odd and the leading coefficient is negative, what does it do on the left end? Does it go up or does it go down? Yeah, it goes up. So now we know the end behavior. Left end goes up. What about the right end? What does the right end do? It goes down. Right? And that's all from the bottom of page 2, right? Or the top of page 2, right? The leading coefficient is negative, and the degree is odd. So the left end goes up and the right end goes down. And now we can, using deductive reasoning, okay, sketch the graph of this polynomial function. Okay. Can I erase this?
Yes.
Okay. And I provided you with x and y axis. So let's graph the x-intercept, starting left to right. So minus 5 stays out here, okay? And then we have minus 2, roughly right here. And then we have 1, roughly right here. And then 3's roughly right here, and 4's roughly right there. Okay. We're not looking for perfection. Okay, just crude sketch. Well, the right end goes down, so the far right x-intercept is 4. So the graph's got to go down at x equals 4. Okay. And the left end goes up, so at this far left x-intercept, graph has to go up. Okay. And now we got to figure out what's happening in between. Okay. So we said at x equals minus 5, the graph's going to touch and churn, right? So here at x equals minus 5, graph has to touch and churn. At x equals minus 2, because the odd multiplicity, graph has to cross. So the graph has to form a turning point and then come down and cross at x equals minus 2. At x equals 1, the multiplicity is even. And so the graph has to come up and touch and turn here at x equals 1, right? So somewhere, we don't know exactly where, but it's going to form a turning point, come up, and just touch and turn, right, at x equals 1 on the x-axis. And then at x equals 3, multiplicity is odd, so it's got to cross. So there has to be, the graph has to form a turning point between x equals 1 and x equals 3 and cross the x-axis. And then lastly, at x equals 4, the multiplicity is odd. The graph has to cross the x-axis, and it's going down to the right at x equals 4. So the graph's got to form a turning point, come down and cross at x equals 4. So a lot of deductive reasoning in mathematics. Okay? A lot of deductive reasoning. Okay? Any questions on that, ladies and gentlemen? Okay. So now you have everything you need to successfully complete the web assigned homework.